Hey, what's up, everybody? Welcome to the stream today, Nemotron Lab's live stream. We've got office hours. We're joined by two esteemed guests, Adi and Amaya, who are joining from our research team, and we're going to talk about and answer questions that you have about NVIDIA Nemotron Nano V2. That's right, the latest in the Nemotron family thus far. If we want to throw up the slides, Zach, to see our beautiful faces, and I'll popcorn it over to Amaya to introduce yourself, and then we'll go to Adi.
Yeah, hey everyone. So I'm a deep learning scientist. I work on small models. So Nano is of particular interest, and we work right from pre-training to post-training to quantization and distillation. And yeah, to Adi.
Hey everybody, my name is Adi. I work in the post-training team here at NVIDIA. So unlike Amia, my focus is mainly on the post-training side. So into things like how do you give the model instruction following abilities? How do you make it behave in ways that we'd expect LLMs to behave, LLM assistants to behave, and so on. And like everything under the hood regarding post-training.
Awesome.
Thanks, by the way, to invite us, and excited to be here.
Of course, yeah. I mean, it's exciting, and guys, these are two incredibly smart folks who work on these models. So, any questions you've got about how they're building them and anything like that, pop those in the chat. That's what we're here to do today, is just answer questions. I'm going to kick us off with a question that's a little bit more informal, which is, how did you get into research? And specifically, why have you landed at Team Green, NVIDIA? What drew you to this effort? We'll start with this time, Adi.
Sure. Yeah. So I started my interest in language models basically began even before LLMs were a term. So I was interested in speech actually originally. I started working on ways to get people to learn languages. So my interest was always in like, how can I make myself not so embarrassingly monolingual? And in the process of building applications for language learning, speech recognition was quite critical. And speech recognition was one of the early adopters of deep learning. So one of the initial places, like way back 2012, 13, speech was basically skyrocketing because of this thing called deep learning. And so that kind of got my interest. And then basically I was in that stream of deep learning, and LLMs were basically the conclusion of that. Why Team Green? I mean, it seemed to me like a few years ago that, instead of competing in a space where who builds the biggest and best models, you want to be part of where all of these models get built in the first place, the hardware. I was not a hardware person, but for me, it felt interesting to see if there's any overlap between the two, what I could learn about GPUs as well. So that got me interested in NVIDIA. I wasn't even aware that there was a deep learning team at NVIDIA for a long time. And then I was seeing papers come up, and that got me interested and started speaking to folks here. And then I made the switch. So here I am.
A classic pipeline into deep learning. And then, of course, got to get close to the hardware. One of the things that we've been talking about lately is this idea of co-design, right? Or extreme co-design, which is the idea of building models with the hardware together in a loop, a tight loop, in order to get to the most efficient, most useful products at the end of the day. Amaya, how about yourself? How did you wind up where you were, and tell us a little bit about why you landed at Team Green?
Yeah, so I think the way I got interested in this space in general is I saw it as a great conversational interface to access more complex technology. So this was back when LLMs itself were not the technology. We were still in like BERT, Roberta age, and what these models could do is provide ordinary people like me access to complex systems that I don't know anything about, and just talk to them and get them to do something for me. And that's how I got into it. And like over time, in not that long, but in like a few years, everything shifted to LLMs, and they itself became the conversation interface and the technology. So that's what continued. And so I was an intern at NVIDIA actually. And when I was intern and when I came back, so this was like the 6-month period before ChatGPT. And I was just surprised by how quickly NVIDIA pivoted to LLMs and scaled, internal research, infrastructure, everything. And this is just very impressive to see. And that's what, like made me team lead.
I mean, it seems like a classic kind of pipeline, right? It's dope, guys. It's so interesting to hear how the people that are building these models got here. We have a question in the chat from Matt Faraz. Matt asks, "Hello, everyone. Can you guys answer questions about training models in Brev? Training models, most certainly. This is the point. So, any questions you've got about training models, this is the time to ask those. For Brev, definitely feel free to follow up in our forums or in our Discord, which we'll talk about a little bit later. We have a whole team that works on Brev to help you out with that. But in here, I think we've got experts on training models. So let's ask some questions about that. I think we have a question that's been starred in the chat that we'll go to next, I believe. If not, I've got a question that ahead of the our time together today, I trolled through a place that has many questions, which is Reddit, and there are many questions available there. So I guess we can start with one of those as we wait for more people to ask questions, yeah, let's kick off with the first one of those. Yes. This is a classic one. I think people have this question a lot, and I imagine this will lead us to more questions. What makes Nemotron Nano V2 a hybrid Mamba transformer model? What are we talking about when we say this?
Do you want to take that, or?
Yeah, sure. So
first of all, I like Mama transformer model, but we don't have that technology.
We don't have that yet.
That's a transcription error brought to you by myself. I'm so sorry about that. But Mamba transformer.
Yeah. So what makes this architecture hybrid is, in addition to the traditional self-attention layers in transformer, we also have the Mamba 2 state space layers and the FFN layers, the feed-forward layers. So these particularly have an advantage for they don't depend on KV cache as much as self-attention. So they're easier to scale for more inference, longer think traces, along those lines. Yeah, that's about the gist of it.
And why does it have to be hybrid? Because we find that there's like an inherent limitation in non-attention based models. So it turns out that we do still need some amount of attention, which comes with its own set of problems in terms of KV cache, like Amia said, and in terms of just the compute you need. So Mamba, while it eliminates these, we found that we couldn't fully have a full Mamba model. Although there's a lot of work, there's like a lot of small rebel research groups trying to challenge transformers, and I'm sure one of these days we'll find a full non-attentional model that's as compelling. But in our experience, some amount of mixing was useful. So I think in our Nano V2 model, for every 5 Mamba layers, you'll find an attention layer, something along that
8%
ratio.
of attention layers, traditional attention layers.
So, okay, this leads into the second question that I pulled from Reddit, which is, how do those Mamba 2 layers improve inference compared to self-attention? Like, so kind of you've explained what makes Nano V2 hybrid Mamba transformer. So why do we want it to be a hybrid Mamba transformer? Like, what is the point?
So the nice thing about Mamba and state space models, and even if you go way back before transformers like LSTMs and RNNs, these models, the way that they were built and the way that they do inference is that they depend on only one previous latent state or hidden state. So everything that they need to know about what token to generate next, in theory, is completely compressed in the last hidden state. So this means unrolling from one token to the other is basically a fast operation, and at no point does decoding one token need to like look way back in the past of the context or even what it has previously generated. So this lets you generate quickly. And additionally, I think Amir also mentioned KV cache. So we don't have to maintain additional memory while we're doing inference for Mamba layers. So this means you also have, you can have larger batch sizes on a specific GPU. So you can do tokens faster, but you can also parallelly generate more tokens because you have more memory to play with. So this is where like the key benefits of Mamba layers comes into the picture.
Yeah, so you kind of still need the traditional self-attention for maintaining the global context, understanding beyond just the last hidden state, but the Mamba 2 layers then do the heavy lifting as you scale inference.
So, and one of the things I've heard is that this is like particularly well suited to long context, or that it scales well with long context. Is that something that is a benefit to this architecture? Is that a reason why something like Nemotron Nano is good at those tasks?
Absolutely. I think this was one of our motivating principles, like right from pre-training. So we kind of saw the reasoning models becoming more and more powerful and more important. And so the question then is like, if you think reasoning models need more tokens to generate their answers, what can we do to make these tokens show up faster? So it's sort of like first principles, like the more the model needs for reasoning, the faster we should make it in terms of the architecture. And so, yeah, so that was one of the prime movers for the hybrid transformer models.
Classic. Our architecture is keeping up with the innovation, right? That's the idea. We gotta. That's another one of those co-design things. Okay, now a question that's come up in the chat, maybe perhaps less specific to you guys, but something that I want to make sure we talk about, from John McLaughlin 48. Looking forward to learning on how to use the new Spark DGX. So obviously, we just released this new bit of hardware. It's really dope, and it's meant to kind of sit on your desk and help you train, help you do inference, help you tinker. We've got a ton of information about that. We're going to drop a link in the chat about that. And as well, we have this ongoing event right now, guys. I'm going to have Zach pull up the slide for this, which is our NVIDIA OSS week. It's PyTorch's OSS week, kind of across the board. We're going to be there at a number of events. We're going to have some information about all of what we're talking about. So if you want to attend, if you're in the SF area, please check out this open source conference that is going on. You're going to be able to see Sparks in the wild. But if you want more information on specifically the Spark, we're going to drop some links in the old Chatterino to get you going with that. And there is actually already a NIM container for the Nano V2 model that will run on Spark. So if you want to get started with your Spark and Nemotron Nano V2, you can do that. We'll drop that link as well in the chat. How are you guys feeling about the Spark? Is that something that you're stoked about? Have any experience with? Any thoughts?
Yeah, it's just so cool. I saw it physically recently, and yeah, it's just the form factor is so cool, and having that sort of compute that you can just fit in your backpack, that's a pretty good thing. And definitely, just to plug in, yeah, because we talked about, so we have the FP8 and NVFP4 versions of Nano V2 also released, especially for Spark.
FP4 is something that we'll want to talk a little bit more about in a second, but I mean, just so cool. Okay, we've got another question, which is, what is the easiest and graphical way to start with Nemotron? Which is from the chat here. So I'm going to show you guys. I'm going to share my screen real quick on what I think is the easiest and most graphical way to get started. Which is our friends at OpenRouter have actually have an endpoint that you can use. I'm going to ask Zach to bring up my screen so we can see this. And the idea is that you can get started real visually. You just click chat and you start chatting. Maybe we want to create a web app. Maybe we want to test something about, do one of these, which is larger, 9.99, 9.11, these kind of like fun little examples. The idea is that you can get started right here at the openrouter.ai link, which we'll put into the description or into the chat again. And this is like the easy way to get started with this model. You can take this right from here to your to your local environment with the API. So a really excellent tool. So happy to see it brought up on OpenRouter, and you can use it just like you would any OpenAI API compatible model. So there you go. That's the easiest and most graphical way to get started with Nemotron. Okay. I think we have a question from the chat as well, guys, from Sailing and Trice. Lastly, have we found a way to prevent hallucination? Has NVIDIA got any tips to suppress hallucinations? So I'm gonna say maybe not the first part, but what work do you guys do, knowing that hallucination is a problem, knowing that confabulations are kind of a pain in our butts? What do you guys do to help remedy some of that?
Yeah, I think that's a great question, and I think it'll continue to be an important question for the next foreseeable couple of years at least. We have done a lot to reduce hallucinations. Like I remember first models that we played with were just basically rampant hallucinations. Now you kind of have to trick them or trip them up in some ways to get hallucinations. So in our pipeline, what we do is we have like a lot of filtering of the data. So what the data that you train the model can trigger hallucination behaviors afterwards. And it's not like the model has some kind of keywords that triggers hallucination. It's more like if there's a mismatch between what you ask and what you force the model to produce in the training, there's really no good explanation that the model can internally tell itself on, like, this is why I need to generate output Y for an input X. And when you have this kind of setup and you train your model on these input-output pairs, you're kind of giving it no other option but to just make up stuff in Y when there's really nothing in X that kind of lets it make a connection for you. So at the risk of anthropomorphizing the model too much, this is like a good way to just have like an internal check on, like, is my data forcing the model to hallucinate? I can give you one interesting example. When we initially started training the model, there were cases where we had a slight mismatch between the output. So like the output would have like thinking traces, whereas the input might not mention whether the model should think or not think. And so when you have this mismatch and you train your model in this fashion, you could expect the model to kind of arbitrarily start thinking or arbitrarily not think. And while this is not technically called hallucination, it's the same neural pathway. It's just basically doing something that you didn't quite explicitly tell it how to work. So this is one way in which we try to prevent hallucinations, is basically making sure that every question that you feed into it in training has a reasonable answer, and that reasonable answer is the answer that you're expecting the model to generate. So other ways you can trigger hallucination is like you have like sort of a vague question and then you train it to generate a very specific answer. Now, the model is at this point not going to ask you any ways to like refine your question. I think that's a great research direction in itself. But as things stand right now, it doesn't. So it's just going to try to connect the dots. And when you get too much into the dot connecting, that's where you run the risk of hallucination.
So we do have some work going on in that area where we try to through data and training, calibrate the model to say that it's okay to say no or to ask follow-up questions without just directly answering. That's especially useful in like agentic cases, like tool calling and stuff. So
yeah, that's something that's
generally there's the Nemo guardrails. So they do a lot of data filtering and a lot of safety-based filtering that we do, and we employ all of that in our data curation. So that's how we try to minimize hallucinations as much as possible.
It's such an interesting point, right? So because guardrails, we're typically thinking about guardrails on the application side, right? Where we have some application we've built and we want to make sure it doesn't go off the rails, so we guard them, right? That's the way most people are thinking of it. But you're saying that you're actually using that same process during the curation of data to kind of pre-guardrail a little bit and hopefully bake some of that behavior in. Ameya, I've got a question. so first of all, great answer. Dang. Second of all, what are some things you've noticed through your usage of some of these Nemotron models that like help? Like, is there a prompting pattern that you find is useful? Is there some way that you can you can kind of do this from once the kind of weights are locked in, right?
Yeah, sure. So I think when you're trying to prompt, especially the nano series of models, I think try to be as explicit as possible about what you want. We have optimized these models quite a bit for instruction following, for example. So if you get really specific about what you want or what style or format you want it in, you're going to get results accordingly. So yeah, it's like interacting with these models. I've always find that useful is to be very specific and explicit about what you want.
Doesn't get easier than that. Just make sure the prompt's good, guys. Okay, and
well, it might sound easy, but actually, like the things that are sort of secondhand for us might not be the case for the model. So, like think about what you expect the model to do, and kind of see how you can encode that in your
like
prompt.
Always iterate. So
and iterate.
Look at the outputs and iterate on your prompts.
I've heard it said it's like the new version of the mom test, right? Where if your mom can't understand the prompt, then the LLM's definitely not going to be able to understand.
That's a new one. Okay, I didn't hear that
one. We have a question, not a question, kind of a question, saying Nemotron, same thing, right? And I want to make sure that we're clear. So Nemotron is our family of models. It's a lot more than just models, right? It's data sets, it's recipes. All of these things are kind of in the Nemotron umbrella. Nemo is a set of tools that you can use for managing, say, like training or the agent life cycle, or libraries that help you to do these things. So there's definite overlap. Like on our model card, you'll see we use some Nemo libraries to actually train Nemotron. But they're not exactly the same thing, even if there's a lot of overlap.
I would also put it this way: like we use Nemo stack to make our Nemotron models. Yeah. You can use Nemo to make whatever model you want, right?
Or build on top of.
Or build on top of. Yeah, exactly.
Using all of that open data and all, we'll get more into that as we go on. We have another question from Sailing Antrice, who wants to know about the NVFP4 acceleration, how it compares to FP8. So, Amaya, you mentioned earlier the NVFP4 and FP8 version. So, how should we think about the difference between NVFP4 and
FP8? So, I don't have exact numbers to quote here, but it's a significant improvement in throughput and latency. And we spend a lot of time to make these models robust to that quantization to make sure we are delivering the same quality at BF16, FP8, and NVFP4. So yeah, it's a significant improvement in how fast the model will operate, and on specific hardwares like Spark or Jetson Thor, and as much as the quality that we can squeeze out of it.
I think that's the big thing, right? People want to know it's trying to preserve as much quality as possible while giving you those inference gains, as is always the case with quantization. It is specific to hardware, right? So it's not something that's always available. But on the hardwares that it is available on, you can expect that you're gonna get exactly what I just talked about. We have another question that's pretty. It's tied to the other Nemo question, which is: does Nemotron have a library where people who want to share their builds in any way? So I'm gonna let you guys talk about, does Nemotron have a library, which I think is very similar to what we've already kind of discussed, but where people who want to share their builds, we can touch on a bit after that. So does Nemotron have a library? Is this a thing?
I don't know if we're managing a Nemotron library. Like, the way I understand the question is that if somebody builds a fine-tuned version of Nemotron to do something specific, how can they share it? I'm not aware of anything internally that we're managing, but I would imagine for these kinds of use cases, Hugging Face is like the perfect place to showcase anything that you've built on top of Nemotron models. Tag us, I guess, if you want it to be kind of.
We can amplify it.
Yeah.
And yeah, if you have like data sets, recipes that fit into the training framework, like the Nemo ecosystem, then you can obviously, it's all open source. You can just contribute to that if it's not like a model. But yeah, just
And that's, I think, a really important piece, right? So Nemotron itself built with a lot of the Nemo technology, which is all open source. So anytime that your teams release another awesome model, or any of the Nemotron models, you can use the technology that was used to create those models yourself. And these recipes are described in pretty intricate detail in the technical reports that Adi and Amea's team produces. I can also share that we're going to have a GitHub repository that's going to be coming up very shortly, which is going to be a place where you can, if you build like a sweet agent with Nemotron, you can contribute that back as an example, because we're more than happy to work with the community to kind of share and highlight these amazing creations as well. If you have a sweet idea that you've made, please let us know, the community team. This is a great time to bring up some slides, Zach, so we can show them how they could tell us all about their sweet creation through our community channels. So we'd love to hear what you got going on. First, though, we got to tell you about GDC DC. Okay, classic. It's coming up end of the month. It's very soon. A lot of the sessions are getting sold out, so you gotta act very quickly if you're still interested in attending. So this is gonna be next week. I'll be there. We can hang out. Adi and Amea, are you guys making the trek to DC at all?
I don't think so this time around.
But yeah, we'll definitely attend it virtually.
Excellent to hear. We're gonna have lots of people to talk about Nemotron and Nemo there, and then we'll go to the next slide talking about how you can see all of our awesome models on huggingface.co/NVIDIA. This is where we release all of the open models we have. Recently, you may have seen a graphic floating around that shows that NVIDIA is releasing like a lot of open source models, in incredible volumes. And not just models. Again, this is data, recipes, everything that goes alongside them. Not just open weights, right? Open source. We'll go to the next slide. If you have any ideas, or if you've had a brainwave while listening to Adi and Amea share their incredible knowledge today, you can vote on features at nemotron.ideas.nvidia.com. So this is a place where you can deliver feedback directly to the teams building these models, right? So if you have an awesome idea or a feature you believe is missing, you can put this up, this is a place that we can see your ideas directly and help build these models together with the community. We'll go to the next slide. Of course, build.nvidia.com. Check it out. We host all of our models there. You can play with them. Beautiful. Next slide. And finally, if you have awesome community shares that you want to share with us, a great place to do that is discord.gg/NVIDIA developer and the hashtag Nemotron-models channel. This is our Discord. We hang out there. I'm in there all the time. Ask any questions. More than happy to forward those to the teams and get those questions answered if I can't do it myself. And finally, we have as well an email that you can reach us at community@nvidia.com. So this is where you can reach us with any of those. Again, you have a sweet build, you want to share it, send us an email, let us know all about it, and we love to amplify that. And we'll move to the next couple questions at this point, guys. And any more questions you guys have, please slam them in the chat, and then we will get going. Okay, so from Pawnee, we have also, can we know what solutions did NVIDIA use to reduce bias in all forms? I'm focused on it outperforms on certain topics. I even count that as bias. So how did you guys approach in, say, like post-training, kind of making sure that the model was as good at one thing as it was everything else? And how do you approach that generally? What does that process look like to you guys?
So the second part of it is actually quite interesting. Let me try and take that, and maybe
Sure.
So depending on like what pre-training data we use and the post-training data we use, we do tend to see like sort of somewhat of a skewed behavior in terms of performance. So it's sort of normal to expect our models to be very strong in math, for example. because math has like certain nice properties that the model just seems to learn. One, you can have verifiable answers, at least the types of math that we expect it to do. So this sort of naturally makes us, we have the ability to generate more math data and make sure it's high quality. This is a lot harder to do, I don't know, like in some other domains. So the low-hanging fruit is kind of where you would expect highest performance. So to some degree, I think this is a kind of bias in terms of like what kind of data you can get, how you can curate it, how can you ensure it's high quality. Now, whether we want to actively fight this type of bias, I'm not entirely sure whether you want to sort of limit your abilities in one domain just to be equal to another domain. I think we strive to make all of them as high as we can. And some of them just end up being higher for the reasons I initially mentioned. What we do end up struggling with is once we have a model that's really good at math, for example, we've employed a pipeline type of training. So you kind of do a few initial stages of training, and then you kind of look at the model and say, where is it lacking? And what can we do to patch these limitations? So for example, RLHF was employed specifically in areas where we thought it's not quite interacting with naturalistic style responses to user queries. So that's where we applied RLHF. Now the question could be, why don't we do that as much to the point where it's equal to math? But these are like sort of nuanced ways to measure behavior. So like getting a 95% on a math benchmark and a 70% on some kind of chat benchmark, like it's not very obvious how you would compare the 95 and the 70. So in that sense, we kind of take the wins where we can and push the model as much as possible where it needs to be better. So I guess that's my take on like the performance bias. But there's actual harmful biases that we very carefully try to avoid. Do you want to add anything?
Yeah, sure. So so this again, like we have Nemo guardrails that can prevent these sort of responses at inference time, but we also try to bring that back into training. And we have specific teams and people working on identifying these biases in our data set as well as our previously trained models, and then design ways of how we can build robustness against them. And how we can build that robustness in the right way. So it's not just a plain refusal, but adding some context about why this is a topic that the model cannot talk about. And yeah, to speak to Adi's earlier point, so in all of these skills, we during a training process, we explore the ceiling for each of these domains as much as we can monitor, and we always try to maintain the ceiling when we mix all of the skills together. The ceiling itself will expand over time, but yeah, at whatever stage it is right now, we try to maintain it as much as possible.
Yeah, and I will also say that the Nano V2 model was one of the first models where we monitored safety and biases throughout the training process.
Very early in the training process.
So this was like right from the get-go, as opposed to earlier times when it was much later. So we kind of improved on our ability to like quickly get a sense of like, is our model, does it have the propensity to say unsafe things? Or does it have the propensity to just be tripped up by a comment that maybe adjacent to something that is considered unsafe, but not quite. So this was one scenario where we kind of took earlier feedback and kind of monitor it much more closely.
Yeah, it's interesting. Again, what we're hearing is that these are things that are considered not just at the end, right? They're considered throughout the whole process, and they're something that you guys are thinking about right from the get-go. I mean, I think this is reflected in some of those open data sets, right, where we have like CC math. It's not just pre-training for general internet scale data. There's also some acknowledgement of what's to come. A question that I have from your answers, right, is how do you do that? Which sounds dope, right? Which is basically making sure we're kind of hitting all those points along the way. How do we do that without and I'm going to say a bit of a dirty word here, right? How do we do that without benchmarking? Without just making the model really good at those benchmarks and kind of failing outside of that? What strategy exists to kind of smooth out that performance as you go on?
Yeah, so there is always the risk that when we have the amount of data that we have, to just throw everything at it and hope that you end up in a situation where the model isn't like overly skewed. So one way we kind of avoid the benchmarking problem is that we always at each training step, even like at each interval, like each validation interval, we check what our model does on a whole suite of benchmarks, not just one or two. So in our case, I think for Nano V2 it was more than a dozen benchmarks. And only checkpoints that seem to be behaving well on all of these are ones that we kind of consider as candidates for later stages. So if you accidentally do really well on math but bad at anything else, we would consider that like a sort of an unsafe model to work with. So the fact that we're monitoring multiple benchmarks simultaneously reduces the risk of benchmarking. It doesn't completely eliminate it. We still want to like get those high scores, but we want to ensure that we're not like, doing one benchmark as opposed and sacrificing another. And I will also say that our safety benchmarks are kind of internal. So we also make sure that we have like these hidden internal benchmarks that we're constantly looking at. And safety is one of those examples where, we don't win any awards for getting high safety, but we still want to ensure that the model is like as safe as we want it to be, because it's going to be consumed quite widely.
Excellent.
And
Yeah, I mean, go ahead, Amaya.
Yeah, we just try to keep the benchmarks as holistic and diverse as possible. So we are not just optimizing the reasoning axes, but we are also trying to improve instruction following, chat, agentic capabilities, and that kind of sort of helps reduce the risk of just being good at reasoning.
Yeah. Somewhat ironically, if you try to force the model to be good at many things, you do to some degree smooth out the benchmarking problem, because we cannot say our model is great at math and then say let's ship it, because we want it to be great at many things. And now it's not trivial anymore to just benchmarks everything. And not just the benchmarks, right? Even other behaviors. So we want budget control to be something that we can do. So this is not like a number specifically. I mean, everything can be converted into a metric, but it's a behavior that we want our model to be able to do. So we want all these other features. We want like reasoning on-off control to be seamless and like 100%. So all of these other behaviors that we want to encode, they all come into play, and not just like, is the score 95% or something.
Yeah, the benchmarks, just the whole world. It's no problem, right?
Right.
That sounds easy. One thing you mentioned, which is the reasoning budget control, right? Which is something that's new to Nemotron Nano V2. And for people who don't know what that is, how can we think about reasoning? I mean, it seems to me like it's as easy as just don't think for as long. What more goes into it other than just saying, all right, model, that's enough thinking for you? Like, how do you approach baking that into the model instead of just kind of naively cutting tokens off?
So the easiest thing to do is actually to naively stop the model from thinking. And there was research prior to our work on Nano V2 that said that's quite adequate. But in our internal evaluations and checks, we found that while it is true that the model does stop thinking, it kind of does clever things. One of the things we found it can do is, if you tell it to stop thinking, it might close the think tag, which is like a control signal that tells the model to stop thinking. So it might accept that you've closed the think tag, but what we found is that the final answer still has like all the tokens that it would typically use during its thinking mode. So it was kind of sneakily thinking even when you told it not to think. So these were things that we kind of found as we were building Nano V2. And with some more inspection, I think it's probably more prevalent in other models as well. I'm not sure what other groups have done when they've released their models to check this behavior, but we think this is not like something isolated. And so we had to like specifically address that as well. And so that one way to address that is like to actually expose the model during training to like truncated thinking traces. And that seemed to at least make the model behave more in line with what we expect. But at a high level, budget just means you don't want the model to think up to its full thinking token limit. You say, you only wanted to give the model like say, a few thousand tokens, and it has to generate an answer after that. Yeah, it was kind of exciting, adding this feature in. I don't know if you wanted to add.
Oh yeah, so yeah, we have to like think like based on the observations that Adi shared, we had to think about this behavior throughout the training process and the data, and kind of curate it to make the model behave correctly when it sort of suddenly stops in between its thinking.
Yeah, and I've got a graph actually here that we can pull up from the model card that you guys released as part of, I believe, the technical report, which is talking about kind of how this feature winds up looking. And you can see the idea, right, that there's these kind of like cutoffs or plateaus where thinking for longer isn't really giving us like a lot of extra juice for the answer, right? So, and it's so interesting to hear that the training process came in because you noticed that the model was just thinking after the buzzer, right? Like,
Exactly.
you know, we said, hey, put hands down, and someone's still scribbling out the last few sentences. So very, very, very cool to hear that. And again, you can explore this in the actual, with the actual model. We have an example of not just what it looks like when you're looking at it, but also we have an example of how you can actually implement this thinking client in the model card. So that you can explore this with something like, say, VLLM. The formatting on Hugging Face is a bit terrible, but the idea is you can build this out in Python and consume it with the actual VLLM endpoint. Okay, so guys, with that, I think we've got to the end of our questions. We've got 2 more we're going to end on, and then we're going to wrap it. Thank you again for all your time, Adi and Maya. We're going to end with a simple question, which is about some of our courses, our DLI courses and our workshops. You can find the links in the description, but we have workshops for building agents with Nano V2. We have one for a RAG agent. We have one for a report generation agent, and we've got more and more on the way. We've got tutorials on how you can, in a weekend, train a reasoning model. Not as intensely as the Nano team did, but still you'll get some performance out of it. And then the last question we're going to end on for you guys: can the Nano 9B V2 be used on a Jetson device other than Jetson AGX Thor?
Do you want to take that one?
Yeah, I think so. The NIM release, I think it enables use on Jetson devices. Only the FP4 quantization is restricted to the Blackwell architecture, so you can't use that. But I think you can still use the FP8 quantization.
Let's go. Thank you so much, guys, for your time today. Thank you, everybody, for showing up to another Nemotron Labs office hours. Again, any closing thoughts for people, guys, before we sign off for the day?
This was fun. We'll do it again, Chris.
Hey,
yeah, this was fun. Thanks for arranging this.
I'll hold you to it. We'll see you and Adi again in the future.
If I've worked on the model, you can hold me to it. Yes.
All right, guys. Thank you so much, and thank you everybody for joining us. We love doing these. Again, visit our Discord. Send us an email if you got cool, crazy ideas, or use that feature voting. There you go. Have a good rest of your day.
Bye.